And our next talk will be done by Joe Gilet. He is the director and founder of Hidexe NHQ that develops software solutions based on cloud, focused specifically on the leather industry. Welcome, Joe Gilet.
Thank you very much. I'm quite impressed about the avalanche about AI, what we heard now for the last half hour. And Raphael covered big part of the items I wanted to talk about. And thanks to AI, my IT people were able to generate that presentation, which I have the pleasure to present over here. And I would like to start immediately, because we say AI is a very useful tool, but the tool is only as good as the input you put into it. So the biggest challenge for us in the leather industry is fungibility, which means I need reliable information, and instead of a picture, I need a mathematical data that I can enter into the system the way that I'm getting the right answer. The answer of the AI is only as good as the input. So coming on this, there's no pointer, but as you can see over here, the central part is if I have fungible data, I can do whatever I want with it. So I try to push the button. If we relate now AI to the leather industry, we have a few bottlenecks which until today haven't been able to be solved. We can have any kind of data collection as soon as we do not have an automatic transition of this data collection, this data, we still have the human error, which we cannot overcome. Therefore, we did first analyze the process and we say, okay, we have biological limits, who is the human being, as me, and you, as everybody over here. Then second, we have to bring this biological strategy into a systematic operation, which means we have to be able to transfer without any error the collected data into a database. And from the database, of course, we have to bring it into an ERP system, because today nobody can live or work with our quite well-working ERP system. So these were the three stages where we have been thinking about, and one of the solutions was, okay, how do we can eliminate the bottleneck? Not by eliminating people, but by giving people another opportunity to work and upgrading the job and making it more sustainable and more livable. Therefore, we go here. The human being, we have the problem that we have the parallax problem, which means today hides in wet blue or in wet white after samming are running with about 360 hides per hour. It means a human being has to be able to detect, see, classify, identify about, within 10 seconds, about 300 to 400 events on a hide. When we translate this into a scanner system, we are talking about 500 gigabytes within 10 seconds, which is a tremendous amount of data which you have to bring into correlation. And then within this 10 seconds, not only he has to find it over a width of 5 square meter and 3.20 meter width, but he also has to realize if it's positive or negative, if it's a defect or is it just something natural. And based on this, afterwards he has to calculate, okay, is it within a certain area, is it acceptable or not acceptable? So any chess champion in the world could never meet that challenge that we are asking from our sorting people to do today. Then on the second side, we have the decision crisis. Decision crisis means not only that you have to detect the defects and identify them and qualifying them, but also you have 30 different grading criteria, which can be very marginal from one to the next. And all this the person has to do within 10 seconds. So Superman is not, compared to this, is almost, yeah, a beach boy, let's put it that way. And then we have this, the third factor which is in there, is the fatigue curve. If somebody is looking at wet blue or wet white, which is even worse, with a rhythm of 10 heights, 1 height every 10 seconds, within 20 minutes, he's losing between 40 and 50% of his ability to make the separation, especially when the separations are marginal. In addition to the separation and the decision, you ask him to push a button, or if you are digitalized today, like we have in many tanneries, you have a touch screen where the person still has to push a button to communicate his decision with a computer system. So based on this, and there AI found this beautiful sentence at the bottom: the biology cannot compete with 100 million pixels a second scan. It's such a tremendous amount of data which has to be generated today that it's not possible. So we had to find a way to do this. The first logical point, which we started about 10 years ago, was scanning. We completely underestimated the potential of scanning, and we completely underestimated the workload which is related to this. Scanning is something very, very complicated. You can make a copy, or you can make a mathematical analysis of it. It's the difference between 2D and 3D scanner. So we started with 2D scanners. A 2D scanner creates one of these pictures. If you take this picture number 1, you have 75% of a chance that it misses what it sees. Picture number 2 is a little bit more evident. 3 and 4 really give you facts. So when we have a 2D system, it is just an electronic eye similar to a human eye. And you do not see any contrast with this. So you have you only have a picture, and you have a sort of a shadow. What do you do with AI when you have this kind of systems? The AI is just guessing what kind of picture it got and how it can implement it, and if it has seen something before. So it's only purely picture-based analysis with a high error rate, because you have some defects or some events on the hide which look very similar. Based on this, we gave this up, and we found Easy Inspect, which is a system coming from Germany. And Easy Inspect is a multi-angle analyze and picturing. This means we take one picture out of 4 different angles. So this makes every event calculable. So it becomes a mathematical fact. This is very important when we are talking about issues like contamination on the surface, like leather fibers, which usually also do have the same color than the hide underneath. And it can be very easily confused with a small scar, or the other way around. Even more challenging for the shoe guys, pinholes. Pinholes, you do not see them in general in wet blue, you see them only in the crust. With this kind of system, we detect the pinholes also in wet blue or in wet white or wet green or wet yellow, whatever wet we have today. The other challenge is the ununiformity of wet blue, wet white with the humidity repetition over the hide. A 2D system is very sensible to reflection. And if there is a little bit of water on top, it doesn't realize anymore if it is a defect or is it only just water. With 4-dimensional measurement, you can filter it You have to imagine it's like when we are working with 4 angles, we are working with 20,000 different grids, and every grid is one image or one defect, and we can filter out whatever is supposed to be not considered as a defect. So we have the multispectral filtering, and this means just 2D is a digital guessing, and easy inspect is a structural truth, because we know the four angles of the height, of the height and all of every defect. If we bring this to tanneries today are working with clipboards. That's the way we call it out. If we take just this 10 or this 10 or 9, if we take first the technology, the human eye is very subjective and also doesn't work the same way in the morning than in the afternoon, and it's depending on plenty of stuff. Then we have the digital camera. A digital camera is just the human eye and works a little bit more perfect. So when you're moving from a human eye to a digital eye, you're eliminating between 40 and 50% of the error, which is caused by the fatigue of the human eye. If we go to a 3D and multispectral scan, there we are making about 150,000 pictures a second with 4 different angles. These are special designed line cameras. Each of these cameras has already 32 cores and can already digest a tremendous amount of data. Then, if we go to the error rate, we consider today that we have minimum 40% error rate by human grading. You can improve it by 2D, and you're coming down to more or less 20%. The problem is always the false positives, which means when you have letter fibers, a 2D system is not able to separate the letter fiber from a small defect. If you go down to the easy inspect or for the multidimensionals, there we have an error rate below 1%, which is quite small even when you're running 3,000 hides a day. Then we have the surface debris, which means the contamination, either it is dirt, either it are leather fibers, or whatever can happen during the process. And there again, the grader is getting blind because he cannot see the difference, especially when he's standing along a transport belt and he has to watch over 3.20 meters and has to detect fibers which can be at the other end of the belt. So he's getting really blind on this. And on the 2Ds, you have this as false positives. And the false positives, they have 2 impacts. You have false positives and false positives. And the other one, I just forgot the word. A false positive means that your letter is downgraded because it's considered as a defect, but it's not a defect. Or the other way around, a defect is missed, and then you add value on it by retanning and finishing. And then you have to downgrade it at the end of the process. Today, where the value of the retanning and finishing process is as high as the value of the hide, it creates a lot of problems. Then we go to ERP integration, and we all know how our manual sorters are working today. Today we are moving from a manual counter into a digital counter, and then we create an Excel sheet, and the Excel sheet is sent to the office, and the office is typing it over into an ERP system. So we have 3 sources of error in this. If we go to ERP integration with 2D, it's still the same, because with a 2D scanner system, you still need an operator to override the false positives. If the false positives are fibers, dirt, variation in humidity, the operator still has to override, and then afterwards this can be partially digitalized because he pushes the button. But if a person has to put on a touch screen 15 different options with every 10 seconds, you create another high error rate on data transmission. With With the Easy Inspect system, it's automatic. Within 1 second after the scan of the hide, all the data are available, which means the shape of the hide, the position of the defects, every needed data is there. So there's no risk of error, and the data might be used for any kind of application. Either it is for grading, either it is for inventory, either it is for any kind of other tool you need in order to run your factory. Then we are coming to the processing risk. Processing risk means when you have false positives, you put a number 1 hide into a number 2 grade, or if we talk in Brazilian currency, from a tier 1 to a tier 3 to a tier 2. If you downgrade, you are losing value. So which means you all over here know the difference in price between a tier 1 and tier 2. If you have 20% of your hides which are downgraded, you can make the calculation yourself how much money it means. Upgrading is the same story. If you have a tier 2 which goes into a tier 1 and you have to reject it at the final process before you ship it out to the customer, you destroy money, you destroy added value. Or even worse, if you miss it over there and it goes to the customer, this can have a negative impact on your PPMs, on your supplier evaluation, like in the automotive industry or in the high-end handbag industry. So it has multiple impacts, negative impacts to your performance. Then we have the traceability. When we scanned in the beginning, we thought, okay, we scan, and what do we do if we have to find the hide bag? So we found a system which is a matrix printer. We print prior to scan on every hide a matrix code. A matrix code is much more flexible than a barcode and less sensible to deformation. And if we print this on the hide prior to the scan, we create an ID card, which you will see on one of the next pictures. Next to the picture of the hide, we also have the code. And afterwards, when you want to see, okay, there is a hide laying in my warehouse, you just scan the number and you can call up all the technical details, including grading, processing, whatever data you have put into your ERP system and you have made available for information. And if ever you have a claim with a customer, you can go there, you just scan the number, and you will see automatically if it is qualified or not qualified, if it is your hide or not your hide. Then we are talking about the administration effort. When you have manual selection, people are telling us, yes, but we just save 1 person. But you are not saving 1 person, you are saving 5 persons. Because first of all, you have the grading person, you have the grading person that has to enter the data into an Excel sheet or maybe only on a paper, then you have a supervisor that enters it into an Excel sheet, and the Excel sheet is transferred to the office, and there somebody else again is entering it into the ERP system. And like what we are saying, you know, with any kind of ERP system, if you go the wrong information in, you will never get the right information out. Wrong in, wrong out. And no AI in the world can correct this for you. So administration effort manually is quite high. If you work with a 2D system, it's still quite high because you still have the operator which has to enter the data, and you have to analyze it, and you have to check the hides before you send them forward because of the doubts with the false positives and the false negatives. Easy Inspect, we do this directly. So every data is completely registered, and you can shoot it over within the fraction of a second into the ERP system. And here we are coming to the center point. When we are scanning the hide, we are creating a map. It's a 3-dimensional map where every defect is positioned on. And here on the other side, you have the list with all the defects. Every single point over here is a point on the hide. So you really have a roadmap with, let's call it defect amounted, and you can divide in all these different defects are statistically over here, and over here we scan in the same time also the matrix print. The matrix print is a very easy to identify defect, so it's easy to find, and what we create is a full idea. It has nothing to do with the grading, it's just the topography of the height. And then after this, you start to create your grading methods. But this is your quality management, which does this in accordance to your customer requirements, in accordance to your supplier requirements, in accordance to your inventory. If you want to evaluate, with that moment that you scan the height, you know exactly what the money, what's the height is worth within your company. And what do we have here? So this is then what we call the grading engine. In the grading engine, you define the qualities, and this your quality management does. No operator and no inspector decides. You decide, and the system is working to this. So this is a fungible operation. It's always traceable. When you want to change parameter, you just can change any parameter from 0 to 100% within the range. And either you're making upholstery leather and people are looking for 4 squares, 50 by 50 or whatever, you define what's allowed to be in the square and what's not allowed into the square. And this is what you are requesting today from your operators, and they cannot do it physically. Here we have a real mathematical truth where we are working on. And of course, it is reliable. Either it is on Monday or on Friday, either it is in the morning or in the afternoon. Either the football club was good or not good. The system doesn't care about this, and you have a full reproductivity. And if you want to change one of your grading methods, you want to adapt them because they do not come out the way you expect, there is a grid behind where automatically is registered when somebody changes something on the parameters, which allows you to fine-tune at the end of what is the best setting for getting the best result. And of course, you can also do evaluation of all your stock. If you say, okay, now we grade it according to upholstery, and this gives me a certain value, you can say, okay, I want to see how this looks like if I take the criteria of shoe upper, for example, and within a second, you can switch between the grades, and it gives you also a monetary value. What is the best application on the best use for these heights? In what market do you have to send them, or in what production you have to send them? And of course, every grade decision is traceable, which means one height has been graded according to one criteria. You always know how it has been done and why it has been done. As an example, we have a customer using this wet blue. I'm almost at the end. You have an incoming quality control and outgoing quality control. So you can track it on the incoming quality control to monitor your suppliers. And on the other side, you can have different gradings for your production need, and you can have different gradings for your customers. All this you can monitor with the system within a glance and on your mobile phone if necessary. So what do? We create the matrix print first. This makes sure that every height is unique. Secondly, this allows us to make a digital recall. So every height, when you scan it, you just find it back. With this, you can fulfill all compliance requirements because everything becomes traceable, like LWG or ISO or whatever. And you have a PPM security, because the PPM security just means that you can really send to your customer what he requires, and you have no risk of claim. Here, That's where we are talking about the true. When we are talking about 2D, 2D sees only one of these effects. So therefore, there is a lot of guessing in it. If you give to AI only one of these pictures, you have 75% of a chance that you get an error, a wrong result out of it. So you have total loss prevention on this, which when you're sorting a hide in the wrong selection, you lose the whole value and the added value you put into in the production. You have a value-added recovery. You avoid when you have 40 or 50% of wrong selections and you're sending a too good hide to a customer who is looking for lower quality, you are losing money. And the other way, of course, around is the same story. And it's causing claims when you said once two good hides and afterwards you ship a regular grading to the customer, he's disappointed because your hides did not meet what the previous shipment meant. You have the knowledge sovereignty. It stays always, all the know-how stays in-house. If your people leave, the know-how is in the house and it's traceable, it's trackable. Or if somebody is retired, and as everybody knows, wet blue graders are very high-valued persons. And therefore, I'm saying that AI, in combination with fungibility, is a big chance for our industry to move into the next generation. Because here we have the possibility to really optimize and streamline and justify when we are saying that our hides, that our industry is a byproduct industry. We can make sure that we bring the right byproduct into the right industry, lower grade hides into gelatin and the good grade hides into finished leather. Everything, I think we are on a hurry over here. I'm over time, sorry. So the system, for us, the challenge was it has to be internet independent, so it's working with high power computers within the tannery, within the intranet. You are not depending on the internet, and you have no need to use high speed internet connections to compare the pictures. You're phaser resistant. So this means you have no errors because of the 4 angles. And of course, you can scale it up. And you can connect multiple production places together and still working with the same results and the same settings. You're getting the same settings in Brazil than you are getting in Germany or than you are getting in the US or in China. Thank you very much.
Thank you very much, Joe Gilet, for your participation in our forum.